Hi there, welcome to this lecture. Now we're going to talk about the index, right? The Elasticsearch Index. When users like you and I, when we work with Elasticsearch, we're 99.9% of the time dealing with the index, right? And this is the Elasticsearch Index. So for us, if we define an index, for example, for vehicles, right, we deal with this particular structure, which is the logical representation of the actual data. The actual data resides on the disk in something called shards, right? S1 and S2, let's just call it two shards. The actual data resides on the disk in these things called shards, but we rarely deal with this aspect of it. We're usually concerned with the logical representation of the vehicles index or a customer's index or an employee's index. We're dealing with the data and how to load data into the index. So now we're talking about the higher level usability standpoint, right? We're done with the underlying details that I spoke about in the previous lesson. So we're going to get into the topic of creating an index, an Elasticsearch index, and then defining the different documents that can go into this index, okay? So from a user standpoint, if we define an index called vehicles, it's going to have certain types of documents that go into this index. We can have cars, right? So car documents, we can have truck documents, and so on, right? Similarly, if we define an employees index, right, and the kinds of employees that can go into this index would be, things like accountants or, IT staff, clerks, lawyers, basically employees of a particular organization, what have you. So notice the distinction of the index containers, such as employees or vehicles, and the actual types that can go in here. So now let's head over to Kibana and index a document, and then we're going to get into the details of the actual index structure and how to define the structure of the documents that can go into the index and something called mappings. So here we are in Kibana. Just make sure that you have the Elasticsearch instance running as well as the Kibana instance running. Okay, and I showed you how to do that in the previous lessons. So now that we're in the Kibana DevTools tab, let's talk about indexing data, for example, customers. We use the put command and we specify the particular index. Now customers, right? Customers does not exist yet. If I do a get command on this guy and hit play, notice it says index not found exception. There's an error, right? So this index doesn't exist yet, but I could just put a document into the customer's index by specifying the document. So after the index name, I specify the type. So let's say we have, this business has online customers and in-store customers. So I can specify this is going to be an online type of document. And then I specify the ID for the document. So let's just leave it to 123. And then I specify the JSON body as part of the request. This is going to be the actual document. So documents have fields and values. So let's just say the field is, we have a name and the customer's name is Joe Swanson. And the gender, let's just say that this is, of course, a male. It's a male name. And then age, let's just say he's 30. And the total amount of money that this customer spent in our online store is going to be $275.50, let's say. And we can have another field called is new to state whether this is a new customer or an old customer. So is new, we could just say that it's false. Let's just say we've had this customer for a while. He's not a brand new customer. All right, so at this point, before running this command, customers does not exist, and this online type does not exist, and this document certainly doesn't exist either. But if I hit play, not only will the customer's index be created, but the type for online is going to be created as well. And of course, this document is going to be indexed. So Elasticsearch doesn't require you to specify the structure of the index ahead of time. It's able to use the field and figure out what data type each particular field is supposed to have. So it creates a structure for the index. But that's actually not best practice. When you're working with data, you need to make sure that you understand the data. Elasticsearch is not going to get in your way or anything and prevent you from inserting or indexing documents into an index that doesn't exist. It'll just, figure out what those fields are and willy-nilly create the index structure for you. It doesn't get in your way. So it supports ad hoc indexing like this, but this is not best practice. You as the data worker should understand your schema and the structure of your data, and you should define that structure ahead of time, the different mappings and the different data types for each one of the fields. What are they going to be? What are the field names? What are the data types? You should know that ahead of time, and you should define that. This document has made its way into the online type in the customers index. So let's examine the structure for this index. We could use the get command and just do get/customers. We don't need this document anymore. And just hit play, and notice that this is the structure that has been created by the document that we tried to index. And because of that, these fields, such as gender, is new, name, and total spent, were figured out by Elasticsearch, and the types were chosen by Elasticsearch, the types for each one of these fields. And then down here in the settings, notice that it assigned the number of shards to be 5 and number of replicas to be 1. Okay, so the structure of an index, right, is not the actual document that we index, is the structure of the index. If we sort of summarize it, inside of the customer's definition, we have mappings and we have settings. Okay, this is basically the raw structure. We have mappings and we have settings. The mapping is going to contain the details about each one of those fields, right? The name field should be a string, the gender should be a string, the age field should be an integer, the total spent field should be a float, and so on. So that's what mappings contain, and settings contain higher level information about the index, how many shards it's going to have, how many replicas it's going to have. So this is the bare minimum. This is the structure of how to define an index. And Elasticsearch was smart enough to figure it out on its own, because the document that we sent to Elasticsearch was indexed, and Elasticsearch was able to figure out based on the fields how the structure should be. But this is not the right way of doing it. You want to define your structure separately first before indexing any documents. So let's talk about how to do that. For now, I'm just going to delete the customer's index and just hit play, and that's going to delete that index structure as well as the documents and the types that exist in this. So let's go over the syntax of how to create an index. We use the put command and we specify the name of the index. So we'll just say customers. And then we have the details in the JSON of what the structure should be. So as I mentioned, an index has two parts, the settings and the mappings. So let's first figure out the settings. So in the settings object, we're going to have two very important fields, such as number of shards, and we can make this be 2, and number of replicas. Now let's just say there's going to be 1 replica, meaning there's going to be 1 copy for each one of the shards. So that's settings. After settings, we also have this thing called mappings. Okay, and for now, I'm just going to leave mappings as empty. Okay, so let's hit play. Oops, it's saying parse exception failed to parse content to map. The issue is right here in my JSON, after the settings word, I need to make sure I have the colon. Okay, that's just standard JSON right there. Want to make sure you have the colon followed by the actual object. Okay, so this is the object, this is the title for that object, this is the object, and this is the title for this object, and this is the empty object for mapping. So we have two components, settings and mappings. So let's hit play, and there you go. It says acknowledged true, shards acknowledged true. So now if we do a get on the customer's index, let's get rid of this stuff. We just do a get on the customer's index and hit play. Notice that the details have been applied. Look at the number of shards. It shows 2, right? Before, if I was to just index any old document, it would default to 5 shards. But because we specified in the settings, the number of shards is 2 and the number of replicas is 1. And notice the provided name is customers, right? That's what we have here. The mappings field is empty. We didn't specify any mappings, and this is going to be the types, the type of customers. We have online customers and we have in-store customers. So now that we have the settings out of the way, let's define the actual mappings, right? What kind of documents are going to go into this customer's index? So for that, we have to use the put command again. And after the index name, we put a slash, and then we put mapping, and then we put a slash, and then the type of document that will be associated with this mapping. So let's just say we have online customers and in-store customers. So let's just say this is an online customer. Inside of in this JSON document, we have to specify the different fields. And that goes into an object called properties. So we'll call it properties. And in here, there will be the different fields that we'll specify. So our customers have a name field, okay? And the characteristics of the name field go into this name field object, okay? So the type for this name field is going to be, let's just say string. And this data type is actually deprecated in Elasticsearch 5 onwards. So if you're using an older version, this will work. But if you're using the newest version, the string will not work. But I just want to put string for now so that you can see what happens when I use this data type for this. And then we have to specify the analyzer. Remember, we spent a whole lesson talking about analyzers, and we're going to continue on that topic, but there are a couple of different standard analyzers that we can use that are built in. One of them is standard. There are various different analyzers, built-in analyzers that Elasticsearch provides. One of them is standard. You'll see, white space, and there's just a couple. We'll be testing analyzers later, but basically this analyzer is used for this particular field called name, meaning that whatever data that's passed in is going to be split on white space. It's going to be lowercase, and it's going to be stored in the inverted index using this analyzer. Okay, so we spoke about the analyzer in the previous lesson. This should be somewhat of a review for you, but this is how you define the analyzer for a given field. And this built-in standard analyzer is going to be applied not only during searching, but also during indexing. Okay, so this works in both directions. Indexing data into Elasticsearch, the data is going to be divided up. All the texts and terms are going to be split on boundaries, and the data is going to be lowercased. All the punctuations are going to be removed. Stop words are going to be removed, right? All the things that we talked about in the previous lesson to format the text before it gets put into the inverted index. So that's for indexing, and for searching, it's going to transform the text in a similar way to match it to the data that exists in this field. So if we hit play, notice it's saying deprecation. The string field is deprecated. Please use text or keyword instead of, for this name field. So as I mentioned, we have to change this to text, and now it should work. There you go. It says acknowledge true. And now let's examine this customer's index. If we do a get command on just the customers and get rid of this, we don't need this anymore, and hit play, notice it in the mappings field, we have, for the online mapping, we have this property with the name field, and the analyzer that's used is standard. Okay, so similarly, we can have the in-store mapping, right? We have two different kinds of customers. We have online customers and we have in-store customers. So I'm going to take this as an opportunity to give you an assignment. So pause the video and try this out on your own. The assignment is for you to define the in-store customer type and define the fields, just define the same name field for that, just so you can get some practice. Okay, so pause the video now, try that out, and then you can resume to watch my solution. All right, welcome back. Hopefully you took a shot at completing that. We just need to change this to a put method, and we specify after the slash that we want to modify the mapping, and we put a slash and we say in store. Okay, the mapping is now going to be in store. It's not going to be online, and the JSON document is going to have the different attributes. So we have the properties field, and the object inside of properties is going to contain the different fields. So the first field is name. The settings for the name should include the type. So the type for this name is going to be text. And the analyzer, for now, just use the same one that I used, the default standard analyzer. And that's it. Let's just hit play. and notice acknowledges true. And now let's examine the structure of the index. We could do get request on customers and hit play. And there we go. We have the online mapping and we have the in-store mapping, okay? And then this is the settings. So if we collapse this customers index structure, we can actually, navigate using this handy tool. Just click on the arrows. Notice we have the mappings in the settings section. Inside of mappings, we have the online mapping and in-store mapping. So this structure should give you an idea. In the mapping section, we have the two mappings, and then we have the settings, okay? Inside of settings, we have, other fields, such as the index field, and that has the details about the index, okay? So this should give you a good overview of how the structure of an index should be defined. And this is referred to as the schema. Schema meaning the structure of the index. What are the different fields that are going to be in the index? What are the fields types, right? And what kind of documents are going to go in there? That's where the mappings are defined, the different types. We have online customers and in-store customers. So here are the different field types. A given field such as name or gender, age, total spent, so on. The different fields can have these kind of types, such as text, byte, short, integer, long, and so on. Not important to memorize these right now. You can always look them up in the Elasticsearch documentation. There's a couple of other data types that I didn't mention here, but you can read up on them on your own. But these are the common ones that you'll see being used in the industry. So I'm going to complete the rest of the structure for the in-store customer type, and I'll leave the assignment for you for online customers for you to complete on your own. We have a couple of more fields to add to the mappings, such as the gender field, the age, the total spent is new. So I'm going to add those fields to the in-store mapping, and I'll leave it for you as an assignment for adding those fields in the online mapping. Okay, you can work on that on your own. So let's add that to the customers index for the in-store mapping. I'm going to add those fields. So what's the syntax? We do underscore mapping, and then we specify the particular mapping, and it's going to be in store. So there you go. I completed the gender field. Now let's work on the age field, and inside of the age field, we have to specify the different attributes, such as the type. What's going to be the type for this field? So since this is a number, I'm just going to say that this is of type integer. And that's all we need for the age, right? We don't really need an analyzer because analyzers are used to parse textual information when you're splitting up on white space and lowercasing everything. That's what analyzers do. But for a numeric field like age, we don't need an analyzer, right? It doesn't really exist for numeric fields. So we got the age out of the way. Then we have the field called total spent. And this field is going to have a similar setup. The type for this field is going to be, since this is a decimal amount, type is going to be float. And then finally, we also have the is new field. And this is just going to have the type called Boolean, which is, either true or false. That's what this type means, in case you're not aware. So there we go. We've defined the rest of the fields. We've got age, total spent, is new, and gender up here. For gender, it's a text field, so we have to define an analyzer. For these, we don't need an analyzer because these are either numeric or, it's a true or false, yes, no kind of field. So there's no analyzer needed there. So let's hit play. And there you go, acknowledge is true. If we just do a get on the actual customers and hit play, notice that inside of the mappings, let me collapse this so we can understand. So inside of mappings, in the in-store type, that's the one I was just working on. Expand that. Notice that we have the properties. We have the age property, gender property, is new property, name property that we defined earlier, and then total spent. And then properties are basically the different fields. So take a moment to do the same for the online type. Okay, that just has one field for now. Just go ahead and complete that on your own for the online type. Now, if this index didn't exist and this was the first time we were creating this index, then we can actually, in just one request, create not only the settings, but also the mappings. Okay, let me show you how to do that real quick. Let's just delete this index and hit play. There's no, customers is gone. if I do put on the customer's index, right now this index doesn't exist, we deleted it. So inside of this, the structure, we have to define, the JSON structure. We need the settings field and the mappings field. So I can define the mappings field and state the different properties that we built, such as like that. Right, these are different properties, and we had gender, age, total spent, and then we have one more property called name, which is going to be, pretty much the same as gender. So I'm just going to copy and paste that at the end here, and just call this, instead of gender, it's going to be name. And just following these curly braces, just make sure our syntax is correct. Inside of gender, age, total spent is new, and name, and so on. So we can collapse this properties, right? And we're inside of mappings, and we're inside of here. So inside of properties, we have all of the different fields. So after mappings, we can define the settings. And that just had those, number of shards field, and we just left that to 2, and the number of replicas, we left that to 1. So like I said, I deleted the customer's index, and I'm recreating the structure for that index like this in one go, defining the mappings and settings as part of the same request, okay? And right now it's going to show this error. It's saying expected one of the following get, put, post, and delete, and so on. Basically, it wants us to capitalize this, so we'll just do that. And then let's just hit play, and looks like we've got a problem. And if you look at the reason, it's saying failed to parse mapping properties. So this is properties. Inside of here, we have all of the different fields, right? But here's the magic question. Fields for what, right? Fields for what? We've got a customer's index, and fields can belong to the different types of customers. We can have online customers, and we can have in-store customers, and we're not even specifying that here. We're just saying that these fields belong to this index, but we need to specify the type, right? In our previous example, we went over, with vehicles index, we have different kinds of vehicles. We have motorcycles, we have cars, we have trucks. Each one of those type of documents may have different fields. So we need to specify the type of mapping that these fields are associated with. So in our example, we've got two kinds of customers. We've got online customers, and we've got in-store customers. So we need to specify the type to which these fields belong to. That needs to be going inside of the type name, and the type for this document is going to be, for example, in-store or online. So let's just call this online. And then we have to put everything that is inside of all these fields, the properties field, inside of the online field, okay? And let's hit play, and there you go, that worked. So we need the mappings field. Inside of the mappings field, we have the online field, and inside of that, we have all these properties. And this is where we define the kind of structure associated with this type of document. The online documents are going to have gender fields, they're going to have age, they're going to have total spent, is new, name. That's what each document, those are the kind of fields that the document will have. And these are going to be documents, of course, associated with the online customer. So to see how this is going to look, again, we could just use the get command on the customer's index, just like that. And, you'll be able to see how Elasticsearch is storing all of this stuff, okay? It tags on some other additional fields like UUID, version, and created all this other stuff is added on to the response from Elasticsearch when we do a get on the index. So this mappings, we only added for online. After we deleted the index, I re-added it only for online. You can go ahead and add it for store types. Make sure you're taking the time to actually do what I'm telling you. When I ask you to, add a type or modify the structure of the document, you should do that to get the practice, okay? Don't just watch this video, because most of the work is in actually doing, not really just watching the course, okay? So make sure you're putting in that time to get the practice required with using Elasticsearch. But hey, listen, this lecture is already getting quite long, so I'm going to wrap it up here. We're about to hit the 25-minute mark. So we're going to continue on this. We're going to continue this lecture in the next lesson. So stay tuned. I'll see you soon.